is about Biot Savart's law. We know source of magnetic field is moving charge or current carrying conductor. That was confirmed from Oster's experiment, isn't it? And the relation between intensity of magnetic field and the current is given by the law called Biot Savart's law. So the importance of Biot Savart's law is it gives the relation between intensity of magnetic field and the current which creates the magnetic field. For this, consider a conductor of small current element dl carrying current I, and in order to find out magnetic field at the point P, here this is a conductor carrying current, here this is a conductor carrying current I, and here we have to assume a small current element means small length carrying current. So this is a current element dl which is at a distance r from the point. Here the P is a point where we have to determine the magnetic field. So the point P is at a distance r from the current element, and theta be the angle between the current element and the distance. So this is the assumption. So once more, assume a conductor, current carrying conductor carrying current I, and we have to assume a small current element dl. Right. P is a point distant r from the current element, and theta be the angle between the current element and the position vector r. Now, according to Biot Savart's law, Biot observed that the magnetic field, the small magnetic field at the point P, the small magnetic field at the point P due to this current element, it may depends on what are factors. It depends on current. As current increases, normally we know that magnetic field increases, right? And length increases, then again the magnetic field increases. So Biot and Savart, they observed that the magnetic field due to this current element is directly proportional to current, and it is directly proportional to current element dl, length of the current element dl. It is inversely proportional to distance square. Similar to Coulomb's law, as distance increases, what happens to force? Force decreases, or distance increases, what happens to electric field? That also decreases. So similarly, the magnetic field to the current element is inversely proportional to r square. It obeys inverse square law. And they also found that it is directly proportional to, Biot and Savart also found that if the point P is here, if the point P is here, what is the value of theta? Theta will be 90 degree. And if the point P is here along the line of the conductor, theta is 0 degree. And they found that at 90 degree magnetic field is found to be maximum. At 0, if the point P is here, theta is 0, and they found magnetic field is found to be minimum. So they have also observed that the magnetic field depends on some sin theta. So magnetic field is directly proportional to sin theta. So this was Biot and Savart's observation. Magnetic field directly proportional to current, directly proportional to the current element, inversely proportional to distance square, and directly proportional to the angle sin theta. And hence by combining these, we can write dB proportional to I dl sin theta divided by r square, or dB. How will you change the proportionality sign? By a constant, isn't it? Here the constant is mu 0 by 4 pi I dl sin theta divided by r square. So magnetic field due to the small current element is given by dB equals mu 0 by 4 pi I dl sin theta divided by r square, where we know I is the current carrying conductor, dl is a small length of the conductor, and in short we can write I dl is a current element, current carrying conductor having length. So the I dl is called a current element. I dl is the current element, and theta be the angle between the displacement vector and the current element. So Biot Savart's law is dB equals mu 0 by 4 pi I dl sin theta divided by r square. Thus we can say magnetic field is due to which one? The current element. Thus magnetic field is due to the current element. Magnetic field is due to current element. Okay children. And the constant mu0 is called, mu0 is a constant, it is called permeability of free space. Permeability of free space or permeability of vacuum. Okay, in electrostatics we know epsilon 0. Epsilon 0 is permittivity of free space. Here it is permeability of free space or vacuum, and its value was found to be mu 0 is 4 pi into 10 raised to minus 7. That is the value of mu 0. And what is its unit? Unit of mu 0 is, from this we can write the unit of mu 0. Mu 0 equal to dB. We know magnetic field unit is Tesla, isn't it? R square, distance square, meter square, by I, ampere, dl, length, meter, sin theta, no unit. And this can be written as Tesla meter per ampere. So the SI unit of mu 0 is Tesla meter per ampere. So hence mu 0, the value is 4 pi into 10 raised to minus 7 Tesla meter per ampere. That is called permeability of free space or permeability of vacuum. We know Biot Savart's law is dB equal to mu 0 by 4 pi ideal sin theta divided by r square. Now we can express Biot Savart's law in vector form. In vector form, it can be represented as vector dB equals mu 0 by 4 pi I into dl cross r divided by r cube, because here there is sin theta, no, sin theta relation. Therefore, it can be written as the cross product of two vectors. What are the two vectors here? dl is a vector, r is a vector. So we can write dl cross r divided by r cube. Why it comes r cube here? Because dl cross r is dl into r into sin theta. One r is there, no? If you put r cube here, r get cancelled and you will get the original value as r square. Okay, so magnetic field in vector form can be written as dB equals mu 0 by 4 pi I into dl cross r divided by r cube. And from the formula, we can say that the direction of magnetic field is always perpendicular to the plane containing dl and r. Okay, and the magnetic field is given by right hand thumb rule or right hand screw rule. Already we have discussed. Magnetic field due to a current carrying conductor is given by right hand thumb rule. For easy understanding, now we can compare Biot Savart's law and Coulomb's law. The electric field from Coulomb's law is, we know vector E equals 1 by 4 pi epsilon 0 q by r square. That is the electric field due to a point charge. Similarly, magnetic field due to a current carrying element is dB equals mu 0 by 4 pi I dl sin theta by r square, and this is obtained from Biot Savart's law. Okay. Now what is the comparison between Biot Savart's law and Coulomb's law? Both are long range force, because both depends on, as distance increases, what happens to electric field and magnetic field decreases, but it extends up to infinity. So both are considered to be long range force. And both inversely proportional to r square, isn't it? So electric field is inversely proportional to r square, magnetic field is also inversely proportional to r square. So both field depend inversely on the square of the distance between the source and the point of observation. Okay, so both obeys inverse square law. Now, electric field is due to charge, which is a scalar quantity. But magnetic field is due to current carrying element. This is considered to be a vector quantity. So that is the main difference between electric field and magnetic field, or Biot Savart's law and Coulomb's law. Electric field is due to a scalar quantity, which is electric charge, and magnetic field is due to a vector quantity, that is current element. Okay. Next point of difference is electric field is always along the line joining the source and the point of observation, but magnetic field is always perpendicular to the plane containing vector r and ideal. That is like this. For example, if a charge, electric field is due to a point charge, that we know. So if a charge is here, electric field is due to a point charge. So here electric field at the point is, what is the direction of electric field? If this is a positive charge, electric field is outward. If it is a negative charge, electric field is towards the charge. But anyway, it is along the line joining the charge and the point of observation, along the line. But what about the magnetic field? Magnetic field, the direction of magnetic field at the point P is always perpendicular to the plane containing dl and r. This is r, no? So, direction of magnetic field is perpendicular to the plane containing idl and r. So, it is not along the line. Line joining means this is r. So, it is not along the line joining the current element and the point, but it is perpendicular to the plane containing idl and r. So, that is the main difference between Biot Savart's law and Coulomb's law. Now, as in a general case, we can say here there is no signed relation, but here in a Biot Savart's law or to find the magnetic field there is signed relation. So, that is the next difference. The magnetic field depends on sign of the angle between idl and r, but no such relation is found in Coulomb's law for the electric field. So, this is the main comparison between Coulomb's law to find the electric field and Biot Savart's law to find the magnetic field. There is an interesting relation between mu 0 and epsilon 0. We know mu 0 is permeability of free space and epsilon 0 is permittivity of free space. Okay, if you take mu 0 epsilon 0 and it can be written as mu 0 by 4 pi into 4 pi epsilon 0. What is the value of mu 0 by 4 pi? It is 4 pi into 10 raised to minus 7, that is mu 0 divided by 4 pi into 4 pi epsilon 0. We know 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. That already we have discussed in the first chapter. So, 4 pi epsilon 0 can be written as 1 by 9 into 10 raised to 9. Cancelling 4 pi and 4 pi will get 1 by 9 into 10 raised to 16 and it can be written as 1 by 3 into 10 raised to 8 the whole square. What is this 3 into 10 raised to 8? You know it is velocity of light. So, the interesting relation is mu 0 epsilon 0 equals 1 by c square. So, magnetism and electricity are interrelated. Okay, magnetism can produce electricity and electricity can in turn produce magnetism, and the relation between them is mu 0 epsilon 0 equals 1 divided by c square. Here c is the velocity of light and the relation between electricity and magnetism mu 0 and epsilon 0 is 1 divided by c square. Okay.